Okay, let's get started. Today we're doing day 34. We're going to multiply and divide rationals. And we start with multiply and divide because it's actually a little easier than addition and subtraction. So we're going to start with multiplication division because it's a little easier than addition subtraction. First thing that we're going to do is factor the numerator and denominator. We're going to factor the numerator and denominator. Remember that the numerator is the top and the denominator is the bottom. So you can't do any of the problems in this unit unless you're factored. Our next step is going to be to set the denominator equal to 0. So the denominator is the bottom. We're going to set the denominator equal to 0 to find any kind or any values that make the expression undefined. So when the expression is undefined, we call these restricted values. And not always, it depends on the variable and the problem, but most often it ends up looking like X is not equal to these numbers. These are restricted values. X cannot be this number. We will divide out common factors, and when we divide out, we're going to mark them off. We're going to divide out common factors, so we'll mark them out. And then we're going to multiply straight across, and we're going to double check that it's simple or simplified. So there's two different flavors of problems that we're going to do. We have this first one that looks obviously different than these. So these are monomials, and these are a list of factors that could be binomials, or this is a trinomial. It's got 3 terms. So they look a little bit different, but the way that we work them is still similar. So it doesn't matter what the problem is, you got to check to see if they're factored. And what's nice about example A and B is that these are both fully factored. So once you are fully factored, oh, you need the code, right? Let me get you the code. Okay. Can you see the top one? And when you're ready for the second one, please speak up. Like, tell me that you need it. So the first one and the second one are factored. And when they're fully factored, you can go ahead and write down restricted values. This is part of your answer. So restricted values, things that X or Y cannot be. So with the first one, we look at the denominator. And you have an X and you have a Y, okay? X cannot be 0 because it would make the whole denominator 0. Y cannot be 0 because it would make the whole denominator 0. And we can't divide by 0. And so I'm going to have to jot that down, that X cannot be equal to 0 and Y cannot be equal to 0. B is also factored, so I'm going to have to look at the denominator. I'm going to look at the bottom. And X cannot be anything that would make one of those terms equal to 0. So for the first binomial, or the first factor, X could not be positive 1 because it would make that equal to 0. X cannot be positive 5 because it would make that term or that factor equal to 0. So X cannot be equal to positive 1 or positive 5. So it can't, it's always the opposite. Inside the parentheses, it's opposite if everything is fully factored. To figure out the factors, the restricted values for this one, we have to factor the denominator first. So to factor the denominator first, I end up with the numerator stays the same. And y'all are going to get awesome at factoring. For the denominator, this is fast factoring. I don't give you anything more difficult than fast factoring. So we're thinking of what two numbers can multiply to give me 8 that can put together to make me 6. Yep. 2 and 4 will work. 2 and 4 will work. And I look at the middle term. It is positive, so the 4 will be positive. Anytime they're both positive, then both the factors are actually positive. Now that I am fully factored, I can actually jot down my restricted values for example, C as well. So X cannot be equal to what and what? -4 and -2, very good. X cannot be equal to -4 and -2. The order that you list them in doesn't actually matter. If you see them on a test, they could potentially be in numerical order, which means it'll be smallest to largest, but it is not incorrect if you put them in the order in which you see them. It's not incorrect. Now, from here, so when you have them like this, these problems are actually pretty simple. You mark out any factors that you see repeating on the top and the bottom. If you have a match on the top and the bottom, numerator and denominator, then they cancel out or they divide to make 1, technically. So looking at, we're going to come back to example A, but B and C work the same. So for example, B, do you see any factors that are identical in the numerator and denominator? Yeah, the X minus 1. So this is exactly the same in the numerator and denominator. So I mark it out. And guess what? All I have to do is rewrite the problem. So I just rewrite with what I have left. That's it. And these are my answers. Both of them are my answers. For example, C, do you see any repeated factors that match in the numerator and denominator? X plus 2. So you mark them out and we'll rewrite the problem. Both of these are your answer. I can usually tell who's just copying or Googling an answer because you're not going to see these little cancel out marks. And also, because I tested it myself, a lot of times when you search up the answer, it doesn't give you the restricted values either. So if I see that you're not showing sufficient work to tell me that you actually did your own work, you get a 50. Please make sure you show your work. Please make sure you're doing it yourself. It is totally okay to look things up to get confirmation or to see if you're on the right track, but you need to know how to do it yourself and you need to show me the same work that I am showing you. For the first problem, these are the ones that you actually are going to show me a lot of work on. So I'm going to do this in 2 steps. First thing I'm going to do is simplify the numbers or the coefficients in front. And then I'm also going to gather up looking for words, the X and the Y. I'm going to collect them. And since we're dividing, we have to subtract. I forget, this one's actually easier. We can do it all in one step. So when I look at the coefficients, I have a 10 and a 6. Does 10 over 6 reduce? What? Yeah, they're both they're divisible by 2. So I can definitely reduce those. They both divide by 2. So I'm going to get 5 and 3. And then anytime that we are dividing, we subtract exponents to the bigger one. So if the bigger exponent is on top, we subtract to the top. If the bigger exponent is on the bottom, we subtract to the bottom. And so I've got an 8 and a 4. 8 is bigger. So I'm going to take that and subtract 4. And then here I've got a 2 and a 3. 3 is bigger. So I'm going to take that and subtract 2. Now I'm ready to rewrite. So I will get 5x, 8 minus 4 is 4, over 3y, and 3 minus 2 is 1. I don't have to write to the first power. You've actually learned how to already simplify these. We've already done this type of problem before the first one. Oh, I'm missing. Okay, let's move on. Let's do some more. The next few problems are going to solve the same. The first thing that you have to do with any of these problems in the rest of the unit, you have to make sure that everything is factored. These don't factor, but looking at these, we do have some factoring that we need to do first. So let's just go ahead and work D, and then we will factor these and we will simplify them. So this is the one that I said we'll do in 2 steps. So the first thing that we're going to do is reduce the numbers or the coefficients in the front and rewrite the problem, multiplying straight across, and then we're going to simplify again. So what I look for in the numbers, they can simplify right above each other. They can also simplify like this, like they can simplify diagonally too. So 3 and 2, that doesn't reduce. And neither does 10 and 9. Those don't reduce. But I can start looking 3 and 9. Yes, those can reduce. And 10 and 2, those can reduce. So and sometimes you might need to reduce twice, and that's fine. I noticed that 3 and 9, so this would dividing by 3, this would turn into a 1, and this would turn into a 3. 2 and 10, well, I could divide both of these by 2. And I would end up with 1 and 5. So I've simplified the number parts, and sometimes you have to simplify again. I think we simplified enough, but I'm going to rewrite this, multiplying straight across the top and straight across the bottom. So the coefficients are going to be 1 times 5, or I'm going to get 5 out in front. And then I'm going to look at the x's. When I multiply straight across, when you multiply, you add exponents. So 5 and 3 makes 8. So x to the 8th power. And then there's a y. So 3 and 4 makes 7. All over 1 times 3 is 3. And then there's x's and y's in the denominator as well. 3 and 2 make 5. And for the y's, 7 and 5 make 12. From here, I could jot down any restricted values because that's part of my answer. Every answer has restricted values. So I can jot down, and when you are looking at a problem like this, a monomial in the denominator, it's basically it could be x, y, z, any variables that show up in the denominator, they can't equal 0. So x cannot be equal to 0, y cannot be equal to 0. Bless you. And now we're just going to simplify the x's and the y's. And so 5/3 doesn't reduce. So at this point, you might have to reduce again, but we don't need to. We did a good enough job up here. But here, the x can reduce and the y can reduce. And again, I'm going to subtract to the bigger one. So for my y's, I have 8 and 5. 8 is bigger. So I'm going to subtract 5. For the y's, I have 7 and 12. 12 is bigger. So I'm going to subtract 7 in the denominator. And now I'm going to go to rewrite it. So in the numerator, I'm going to be left with 5 x. 8 minus 5 is 3. And the denominator, I'm going to have 3, and then 12 minus 7 is what? 5. I am fully simplified and I know my restricted values. Again, if you're not showing me these steps right here where you're like showing the work to do the problem, I'm not giving you credit for your homework. Full credit. I'm not going to give you full credit. All right, the next two problems, we're going to have to do some factoring first. And so for the first problem, it looks almost factored. Factored, but this is not fully factored. So we are going to have to factor this first. So we got to factor this and rewrite it. So I still have 1 over x. And then when I factor, I'm looking for the greatest common factor for this one. So it's the biggest number that can go into both 8 and 2. What's the biggest number that can go into both 8 and 2? 2 is the biggest number. And then I'm going to also divide out the x's. And I have 3 here and 2 here. So what's the biggest amount that I can pull out? If I have 3 here and 2 here, what's the most amount that I can pull out? 2, because I can't pull 3 out of both of them, but I can pull 2 out of both of them. So the biggest amount I can pull out of both is 2. And now I'm going to write down what I would have left. So 8 divided by 2 is 4. And if I have 3 x's and I'm taking out 2 of them, then I'm left with still 1 minus, this term matches this term. So anything divided by self is just 1. All right, so I've got the top divided, or sorry, factored. From here, I'm going to look for anything that can reduce. Oh, but first I have to write down restricted values. Can't ever forget restricted values. So I'm going to look at my denominator here. If I have an x in the denominator, well, denominator can't be 0. So if there's just an x there, it means x can't be 0. And then in this denominator, the 4 doesn't tell me anything because it's not even an x. But here for this factor, what could x not be? 1. Now I can go through and simplify. I'm going to actually make this bigger so that they're the same size. There. I just wanted them to be the same level. I'm going to move this too. There. I like that. The way that looks better. So I'm going to do the same thing. I'm going to look and see, do I have any factors on the top that match exactly with factors on the bottom? And these look really similar, but this one has the 4 inside and this one has the 4 outside. So these cannot cancel. Here I have an x and I actually have 2 x's here. So we can simplify that. We can subtract 1 to that. And then here I have a 2 and I have a 4. Does 2 over 4 reduce? Yeah. So this would be 1/2. So I'm actually ready to rewrite this. If I multiply straight across, this becomes 1 times 1, which is just 1. I don't have to write that. And then we have x. And it's 2 minus 1, so it's x to the first power. I don't have to write to the first power. We did not cancel out this factor. and we did not cancel out the factor in the bottom, and we can't forget the 2. So it looks like this. The next problem, I have to also make sure that I have fully factored. And here I'm factored, and here I'm factored, and here I'm factored. And if you want to put parentheses around that factor, you can. But right here, I have to factor this first. So I'm going to factor this. And again, it's fast factoring. And I've got to start thinking about what 2 things can multiply to give me 8 that can put together to give me 6. So everything that's already factored just gets rewritten. And I just have one denominator that I need to factor. And when I go to factor it, I'm thinking of what 2 things can multiply to give me 8 that can put together to make 6. 4 and 2 will work. So 4 and 2 work. My middle term is negative, so the bigger number has to be negative. The 4 has to be negative. And if I had -4, I would have to subtract 2 to make -6. So they both end up being negative, which makes sense because they have to multiply to make a positive, and a negative times a negative makes a positive. Now I can write down my restricted values before I start canceling things out. And I'm just going to go from left to right so that I don't forget anything and write down all my factors based on every denominator term. So here, x cannot be equal to +2, +4, -5, +7. Do y'all agree? Let's write them down. Once I've jotted down my restricted values, these are things that x cannot equal. Then I'm going to mark off any terms that repeat in the numerator and denominator. And they can repeat right above each other, or one could be here and one could be a couple terms over, or a couple factors over. So do you see any factors that repeat in the numerator and denominator? X minus 4, yep, I agree. Anything else? Anything else? No. So we rewrite what we have left. So we're left within the numerator only x plus 3. In the denominator, we are left with x minus 2 and x plus 5. Any questions so far? So this is multiplying rationals. I'm going to give you 15 minutes to start on your homework, and then we're going to do the back. All right, 15-minute timer. And you guys are welcome to come and check your work with me. You have 6 problems on the front. Do not forget to answer question number 1.
This one, if it doesn't have the elevator, they're efficient, like with one, would I just keep it as warranty? Or would I go over here? This one?
Here. Multiplied straight across. Oh, you're saying there's not another Y?
Yeah.
So I multiply straight across first, then rewrite it to make it a little more simple, so I don't have Y here, Y here, Y here, Y here. I simplify it or combine them on the top, combine them on the bottom, and then I just have. I simplify the coefficient and then I multiply straight across and then I divide. So this one I first simplify coefficients and then I multiply straight across. And then I'll simplify the x's and y's.
So simplify coefficients.
Yeah, the numbers. And so 6 and 5 can't reduce, but 6 and 8 are both simplify too. And 15 and 5 kind of or cross like reduce.
So I bet. We have two going into one. How do you have this?
5 goes into 15 3 times, or 5 divided by 5 is 1, 15 divided by 5 is 3. Looks like it has spherical coordinates, but fancy.
Oh, I was really scared.
Y'all still have 9 minutes.
Yeah. He literally said, whoever that junior did. Because you just. Just changed the bathroom. No, in his TV. I was the only one that didn't do it. Oh. I don't know. It's literally just about like watching. I just want to do.
This is just simplifying it, right? So probably X5. It's this one is still.
So I had 5 and then there wasn't an X over here, so it's just X.
Oh, so if it's
So I just multiplying straight across. And like there's just a W, so it just, there's nothing else to multiply. You fit the one very.
I have a question.
like
I'm trying to make it easy. He's trying to make it angry. Yeah. You know, the photo.
Well, I know.
These are so like. Yeah.
Okay. So that one. So
Do you understand?
Yeah,
Okay.
I understand it now. Oh, yeah, okay.
Yo, it's 4 centimeters.
7 minutes. I didn't.
That day we really didn't mess. The only difficult question was the. Yeah. No. It's okay, I'm doing. Friday or something.
Right.
I didn't see it.
so everything's canceled.
What do you do for this?
5 more minutes.
I would like to put the person down. Oh, I'm doing it. That's what I.
That's the only
I don't give about it. I don't really. We do 40. Going back to my OD kit. Oh. Oh, yeah. No, there's real. Look at my stats. What was this one? You know, you got step way out.
Yeah. You're just looking in the denominator, and so, your restricted values are anything that make the denominator equal to zero. So anything that makes the denominator equal to zero. So if X was zero, well, zero. Like, then that would make, 0 times anything would make the whole denominator 0. Y can't also be 0 because it would make the whole denominator 0. Like over here, there's not even an X, so that's not underlined. But over here, X can't be 3 because that would make this denominator equal to 0. So you're just looking at what would make the denominators equal to 0. That's how you get the restricted values. And when they're written like this, it's always just X, like whatever the variables are, can't be 0. When it's written like a factor, it's always the opposite.
That's a goal, really? Really? Oh my gosh. The back heel.
Sure, no problem.
Oh, what a bad Yolington. Come on, Yolington. I'm currently implement that. This one, the Dylan. This Yo, what a slide.
So first I have to factor this denominator. So factor what makes him So as soon as everything is factored, I just look for repeating factors, things that match up with the top. So here I have an X, and it doesn't matter if they're right above each other, or they can also be like in this rational or this range. So I have an X minus 3 and an X minus 3, so those cancel, and an X plus 4 and an X plus 4, so those cancel. And I just write down what
I was saying it's like.
So you just factor that.
yes. I have to factor first with
Oh, you did.
every.
Like for.
Okay.
We cross it. Oh.
Oh, I'm not crossing anything. I'm factoring first. So I have to factor that and I have to factor that. And those are just GCF factoring. So like this one, they're both divisible by 2. So I rewrite it and I divide it out of 2. For this one, they're both also divisible by 2. So I factor out of 2 and write down what
So you're only trying to fix this, basically?
I'm only trying to factor these first. And same thing here, that's GCF factoring, but then like, and this one's also GCF factoring. But like this one's factor, fast factoring. This one's GCF. This one is perfect squares, so it's X plus and minus 8. This one's also perfect squares, X plus and minus.
So it's perfect square, it's always gonna be like this. And then if it's a
GCF, you just factor.
yeah. Okay, the fast factor would be,
Two things, and I'll multiply this term, then that's give you the.
okay, thank you.
Alrighty, we're gonna flip on to the back. And there's a little bit more for us to do. The good news is that if you know how to do the front, then doing the back is not much different. In fact, we're going to turn every divide problem into multiply because that's what we do with dividing by fractions. And so we still have to factor everything. Before we can do anything, we still have to factor the numerator and denominator. We still have to set the denominator equal to 0 and find undefined values or values that make the expression undefined, and we call those restricted values. And then we're going to treat it like a division problem. And when we have division problems, we keep, change, flip, which means we're going to rewrite as multiply. And I'm mainly going to talk about keep, change, flip. So again, that's keep, change, flip. So we're keeping the top fraction or the first fraction the same. We're changing the operation to multiply, and we're flipping the second fraction. So again, KCF stands for I would keep the top fraction the same. I would change the operation, and I'm going to flip the bottom fraction. Or if it's written out horizontally, I'm going to keep the first fraction the same. I'm going to change the operation, and I'm going to flip the second fraction. The second part, yes. I'm so sorry. Did you already submit it? Oh, okay. I'm so sorry. I completely forgot to tell you that. So we're changing our operation to multiply. And along the way, we're going to factor, or we're going to make sure we have everything factored. But this is one thing that's slightly different. Obviously, it's different because we got to flip the second fraction, but it's also different because we have to do this step right here. We have to find undefined values. We have to do that step twice. So you're going to do that again right here. We have to check again. And I'm going to show you that basically what we do is we check the denominator of the first fraction. We'll check the denominator. And then for the second fraction, you have to check the numerator and denominator. So if you check it before you flip it, you're checking the denominator. And then once you flip it, you also have to check the denominator again. So you can just go ahead and flip it and make sure you check both the top and the bottom for the second fraction for your restricted values. And so here, first, I'm going to show you that I'm going to write it out. I'm going to change so that I have the first fraction just the way we see it. And then my second fraction, I'm going to flip it. So I keep the top fraction the same. I change the operation from divide to multiply. I'm going to flip the second fraction. Change, flip. Once you keep, change, flip, you can check for restricted values. And so for this one, again, what I was saying is you can either check it twice or you check the denominator of the first one and you check both the numerator and denominator of the second one. So here, when they look like this, whatever the variables are, they can't be 0. So X can't be 0. Y can't be 0. I don't have a variable here, so nothing to check. And then here, Y can't be 0, but we already talked about Y not being 0 here. You don't have to write it twice. So I have X cannot be 0 and Y cannot be 0. And now from here, I solve just like the front. And so I will reduce the coefficients in front, just like I did on the front side. So it looks like to me that 8 over 8 will reduce. 8 over 8 reduces, and they just both turn into a 1. And then 5 and 15 can reduce. They're both divisible by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. And I'm going to multiply straight across and then simplify. So with these problems, I like to write them out twice. So multiplying straight across, I get 1 times 1 is just 1. And then I'll have x to the 4th, y to the 5th. In the denominator, I have 1 times 3. So I have 3. And then I have x squared, y squared. From here, now I can reduce the x and the y. And again, I'm going to reduce towards the bigger one. So looking at the x's, 4 is bigger. So since 4 is bigger, I will subtract 2. And 5 is also bigger than 2. So I'm going to subtract 2 on the top as well. And now when I rewrite, I am done. So I end up with x, and then 4 minus 2 is 2. For the y's, 5 minus 2 is 3. And then in the denominator, all I have left is a 3. So I am fully simplified. Somebody called for you to leave.
Right now?
I mean, they called while you were in the bathroom, so. The next problem, as I rewrite it, I am also going to factor. So I'm going to give myself a note of anything that I need to factor, because this numerator needs to get factored and this denominator needs to get factored. And these are factor with perfect squares. These are, sorry, difference of perfect square factoring. Take the pass. So hopefully this kind of rings a bell as I go through to rewrite them. Like this one, x squared minus 16 turns into x plus 4 and x minus 4. This is one that most people overlook. So x squared minus 1 turns into x plus 1, x minus 1. So I have to factor first as I rewrite. So I keep the first fraction the same, although I'm going to factor it. And difference of perfect squares says that x squared minus 1 is going to turn into x minus 1, x plus 1. Yes. I'm going to keep the I'm going to change the operation to multiply. And then I'm going to flip my second fraction, but as I flip it, I'm going to keep this the same. So that will be the denominator. But my new numerator, when I flip this up to make my numerator, again, this is a difference of perfect squares that turns into x plus 4, x minus 4. Or it could be in the opposite order. I could have x minus 4 and then x plus 4. And from here, I can go and write my restricted values. So remember that restricted values come from the denominator, except for we have to keep into account or take into account that this was the original denominator. So we have to look at the denominator of the first and both the numerator and denominator of the second. And I'm just going to go through to make it simple. I'm going straight across. So x cannot be equal to positive 1, positive 3, negative 4, positive 2. I already have negative 4, so I don't have to rewrite it, and positive 4. So I have to get all of them and write down, and I don't have to write the same number twice, but make sure you take them all into account. 1, 3, negative 4, positive 2, already have negative 4, and positive 4. So we have 1, 2, 3, 4, 5, 6 restricted values, but we only see 5 because one of them was a repeat. From here, we're going to check for repeating factors, anything that can match up the top and the bottom. And keep in mind that 1 has to match up with 1. So if you have an extra one, you can't match them up with doubles. Like they have to match up 1 for 1. So do you see anything that matches up? X minus what? Yeah, X minus 1. I see one on the top, one on the bottom. Anything else? X plus 4. Yep, those match up. Anything else? I don't think so. So we just write down what we have left. So in the numerator, I have X plus 1 and X minus 4. And then X minus 3, X minus 2. And again, I want to point out that this list is just a list of restricted values. It is not an ordered list. So yes, typically you're going to see it in numerical order, but it is not wrong. It's not an ordered list. So the order doesn't matter. They're still restricted values. Also, the order that you see these in your answer doesn't actually matter. I usually just write straight across from left to right. But if you had these factors flipped or switched, it doesn't matter. We can multiply in any order that we want to. Okay, let's keep going. We've got 2 more examples. And so this one, it is technically a fraction divided by a fraction. Even if you don't see the second denominator, it's still there because anything can be divided by 1. I have to double check and look and see, is everything factored? Yes, this one's nice. Everything is factored. So I don't have to factor anything. And now I'm going to keep the top the same and rewrite it. X plus 2, X minus 2. That's a difference of perfect squares if you multiplied it out. X minus 3. Now I'm going to change the operation to multiply, and then I'm going to flip the bottom fraction. So now the 1 becomes the numerator, and I have X plus 2 in the denominator. Now I can list my restricted values. The restricted values come from anything that is a denominator or was a denominator. So I have to look at this denominator and then both the numerator and denominator of the second one, which really makes it easy because there's no X right here. So I don't even have to think about that. So my restricted values is a pretty short list of X cannot be equal to 3 or -2. From here, I'm going to check for any factors that can match on the top and the bottom, the numerator and denominator. Do you see any that match? X plus 2, anything else? All right, then I rewrite and I'm done. So remember that when I am looking at your paper to see, did you do your own work? I want to see stuff written on there. I want to see factors marked out. We have one more problem that we're going to do. And as we do this and we rewrite it with keep, change, flip, I am also going to check for anything that needs to be factored. So taking a look, that numerator is fully factored. This denominator is not. This is perfect squares. It's going to turn into X plus 2, X minus 2. I got to factor that. I also have to fast factor this one. What 2 things can I multiply to give me 18 that I can put together to make 7? So I'm going to have to factor these things. And I'm going to do it all in one step as I rewrite because I don't want to rewrite twice. So I'm going to keep the first fraction the same. X plus 2, X plus 1 divided by, and then difference of perfect squares, I'm going to factor as I rewrite it. So this becomes x minus 2, x plus 2. Or in the opposite order. Change. I'm going to change the operation to multiply. Flip. I'm going to flip this fraction. And the denominator will be x plus 7. But the numerator, I have to factor it. So what two things can multiply to give me 18 that can add or subtract to make 7? Two things can multiply to make 18 that can put together to make 7. 9 and 2 will work. So if I have 9 and 2, my middle term is positive, so my bigger number has to be positive. And if I have 9, I would have to subtract 2 to make 7. Now I can write down any restricted values. So restricted values are going to come from this denominator along with everything in the numerator and denominator over here because they were both denominators at one time. So x cannot be equal to what? Somebody tell me. Positive 2, negative 2, negative 7, and negative 9. I do not have to write down 2 again. Do we see any factors that match up? That we have a perfect match for the top and the bottom? X plus 2, I agree. Anything else? X minus 2. Anything else? No. So I am ready to rewrite. So I will rewrite with x plus 1 in the numerator and x plus 7 in the denominator. Oh, I'm missing one. X plus 9. I almost forgot you. Yes. All right, we are done. Thank you for taking care of your test.